An array stores a sample of heights found on a mountain. Write a program that will display the index of the element in the array that stores the first peak value. Peaks are elements which store values that are greater than the element before it and after it. Write a program that will display the index of the element in the array that stores the first peak value. And here's an example. So here we've got an array of integers. The index of the first peak value is 2. So 0, 1, 2. This is the first peak value. Now we can see this is the first peak value because the value before it and the value after it are less than that number. Peaks are elements which store values that are greater than the element before it and after it. So there's a value which is greater than that and greater than the one after it. So that's the first peak value. Note there's also a peak value there. This value is greater than the one before it and greater than the one after it. There's a peak value. But we're asked to find the index of the first peak value. So I'm now going to show you an approach to solving this problem. Here we've got an integer array and I've populated it with some sample values, and just graphically we can quickly see that here in index 2 there is our first peak value. So as I'm solving this problem, I'm already asking myself, if I was to loop through this integer array, where would I start? Well, I'm going to tell you that I would start at index 1 to help me solve this problem. I wouldn't start at index 0. The reason is I want to start at index 1 so I can compare this value with the one before it and the one after it. So I'm going to do some data processing there and figure out if this value is greater than that and greater than that. And if it's not, I'm just going to move through to the next one, and I'm going to move through to the next one, etc., 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 until I find the first peak value. So that's where I'm going to start my loop. The second question that comes to mind is, where am I going to end my loop? Am I going to end my loop here? Well, no. Because when I get to this number and I want to compare it with the one before it and the one after it, there is no number after it. So I really want to stop whatever loop I'm going to use here. Not the last index in the array, but the second last index in the array is where I'm going to stop my loop. The next consideration that I have is, what kind of loop am I going to use? Am I going to use a for loop or am I going to use a while loop? I think you can use both. Logically, I'm going to plump for a while loop, simply because I don't know when I'm going to find the first peak value. So I don't know how many times I want the loop to iterate. In this situation, I would be very tempted to use a while loop. Now, if you want to continue, I'm going to show you my solution to this problem. So here we have an integer array. I've called it heights, and there are 6 elements in the array at the moment. As I suggested to you, I'm going to use a while loop to help me solve this problem. And I'm going to use a trick that I like to use in my computer programming, which is to set up a Boolean variable which will indicate a situation within the processing of the data that we're going to be doing in a minute. So I'm just going to set up a Boolean called peak found, and I'm going to set that to be false for now. Now then, while peak found is the same as false, so while we haven't found a peak yet, we're going to loop through the array. Now remember, I suggested to you that we will start at index 1. So to help me control the while loop, to help me control how I'm looping through this integer array, I'm just going to use an integer. I'm going to call it index, and I'm going to set its first value to be 1. And what I'm really doing is setting up so I can start looking at my integer array at index 1. Alright, so let's go into the while loop, and what we're going to do is if heights index, and remember the starter value is 1, if heights index is greater than heights, wow, I really can't spell heights, can I? Index minus 1. So if heights index is greater than heights index minus 1, if heights index is greater than heights index minus 1, and heights index is greater than, is greater than heights index plus 1, we're going to do something. Now what I'm going to do is, if this situation is true, I'm going to say that we found a peak. So I'm going to say peak found is true. Else, I'm going to go into the next, I'm going to move my reference to the next. If I haven't found a peak, I'm going to continue. So I'm just going to move through the array, index plus plus. Else, index plus plus. And that's my while loop. I'm starting at the first element of the heights array, and I'm comparing elements with the element before it and the element after it. And if that situation is true, then I'm going to say that we found a peak. That, of course, is going to kill the while loop. That will stop the while loop. And if I haven't found a peak yet, I'm just going to increment my way through the array. And when the while loop is finished, so that's the end of the while loop, let's display the result. So system.out.println, and all I want to do is see what the value of index is by the time we reach the end of the loop. Let's run that. And it's telling me that the index is 2. So 0, 1, 2. Let's just mess around with this. Let's say this time that the first peak is going to be here. So 300, let's call that 400, and then 380. So there's a peak. So this time the index is 1. Let's run that. There we go, 1. Let's change that again. 300, 400, 500, 600, 700, 600. So this time our peak value is there. So the index of that is 0, 1, 2, 3, 4. This time the result should be 4. Boom! So there is a solution to the problem. Now, this doesn't relate to the problem that we're looking at simply because we're guaranteed to have a peak somewhere in the array. But let's just imagine that there is no peak. 300, 400, 500, 600, 600, there is no peak this time. Purely out of curiosity, let's run this program and see what happens. Oh, what happened? Out of bounds exception. Classic programming error. Out of bounds exception. Why? Why do we have an out of bounds exception? And what is this 6? Okay, so let's look at what's going on. While peak found is the same as false. So we start here. We do the comparison. We don't find a peak, so we move on to index 2. We don't find a peak, so we move on to index 3. This is where index plus plus is doing its magic. We don't find a peak, so we move on to index 4. We're comparing these two values with this value. We still don't find a peak, so we move on to here. This is where the problem happens. If heights index, which is this one, is greater than heights index minus 1, which is this one, and heights index, which is this one, is greater than heights index plus 1. There's nothing here. Java is trying to find the next index, but we're now out of bounds. We've gone outside the array, and Java can't deal with that, so we have a problem. So to help us fix this, we need to think about our while condition. Now, do you remember that I suggested to you that we need to stop the array not here, but at the second last element of the array for our processing to work properly? So let's see if we can figure that out. I want to stop here. So while peak found is false and index is less than this index, because this is the last index that we want to look at. So while peak found is false and index is less than this one. So this is 0, 1, 2, 3, 4, 5. That value is 5. And the length is 6. Heights dot length. So the heights dot length is 6, right? 1, 2, 3, 4, 5, 6. Yeah. Index is less than 6. That's 5. 0, 1, 2, 3, 4, 5. 5. No, we don't want to get there. Let's run it and see what happens. Ooh, that does work. Okay, because heights dot length is 6, and we want to say index is less than 6, which is 5. 0, 1, 2, 3, 4, 5. Less than 5 is 4, and that's the final stopping point in this loop. So take a little bit of time to think about what I've just told you. I hope it wasn't too confusing, and well, I hope it was helpful. Thank you.